At the University of Southampton, we've researched into building systems using cheap parts for a number of years, and we thought that with the Raspberry Pi coming out that we could put a number of them together and build ourselves a supercomputer, really with an aim to inspire the next generation of scientists and engineers to get into science, engineering and high-performance computing. Lego is a very convenient way for us to put everything together. It was very easy to fit each of the Raspberry Pis into a little Lego frame, and by the time we tried to put 64 of them together, keeping them all in one place would have been kind of impossible without something. Lego is great fun to play with, and also very easy for us to be able to test out different designs so that we could end up with something that was quite compact, but also quite accessible to put all of the cabling together with. My son certainly had a huge amount of fun putting together the Lego pieces, trying out different designs, so we hope that other people will have a go at this as well. As soon as we saw that one of the suppliers had stock of the Raspberry Pi, we decided that we'd order 64 of them, see if we could put them together. Each one has a 16GB memory card and then an associated power supply, and then we connected them all together into switches. Each individual computer isn't particularly powerful, about the speed of a Pentium 2 300 MHz. One of the more interesting pieces of power on the machines is the graphics card and the graphics processing. There you're able to get about 24 gigaflops of power. So overall, nothing compared to our large supercomputer that we have, but certainly enough to show the basic principles of doing supercomputing. In order to use all of these computers together, you use something called the message passing interface, or MPI. That allows you to send messages from one of the processors into another processor, and then you divide up your tasks so that each computer is working on a small part of a very big problem. The base software starts from a Raspbian image, and then on top of that we're able to use programming languages like Python, which is very popular, and also tools like Scratch, which allows you to animate characters on the screen. One of the nice things about the Raspberry Pi Foundation is they keep improving the performance of that base image, so sometimes as much as 50% between releases. Over the last 10 or 20 years of doing research into these sorts of commodity-based systems, we've seen the price to be able to get something together go from millions of dollars down to hundreds of thousands, tens of thousands of dollars. What you see here is about $4,000 or £2,500. Indeed, if you were to just use 4 of the Raspberry Pis, you'll be down at the hundreds of dollars price point. That means for the first time that it's accessible for schools, colleges to be able to do this kind of thing at home in their own time and have some fun with them. Our overall aim is to inspire and excite people to get into science, to get into engineering, and by starting with something that's cheap and simple, we hope that people can then go on to understand how to do much more complicated things and how to program computers for themselves.